Welcome to the Jittery Rectangles Random Movement tutorial with a focus on the basic transform move. In this video, we will be using Rhino and Grasshopper to create a regular pattern of rectangles on a customizable grid, which are then randomly moved or jittered in two directions. In this tutorial, you will learn about creating a customizable grid with the series and construct points components, drawing rectangle type geometry in Grasshopper, and using the move transform with random movement in the X and Y directions. In our first step, we are going to set up a grid of points. Like in some of the previous examples, we could just use this vector grid, square grid. I'm going to do it slightly differently this time, just to show you how to set up a custom grid. I will explain briefly at the end why this might be something you want to do. It is a bit more work, but we're going to create our own custom grid. So to do this, we are going to create two series of numbers. So here under the third tab, set sequence, we have the series. And let me just copy that and paste it. So we're going to have two series, which is going to basically be the number of points in the X direction and in the Y direction. So you can see here there are three inputs: the start of the series, 0, the step size, so what's the interval between each number in the series, and the count. So if I want to make let's just start by making a 5 by 5 grid. So I'm just going to double click and I'm going to hit 5 and put that into the count. And I'm going to copy that and paste it and put that into the count here. And so this is basically, if we drop a panel, you can see what's being output. Series of numbers between 0 and 4, so 5 values. So I'm going to use these two inputs into the construct points parameter, and let's just find where that is. It's here under vector point construct point. So the fourth tab, vector, under the subtab point construct point. You can also double click and just start typing. It's a bit hard to find this one though. I used to always just want to type point, and I couldn't even find this construct point component. So you do have to know the name on this particular one, that it is construct point and not just point. So if I take this first series and I input that into the X direction, I have now a series of points in the X direction. And if I take the second series and input them into the Y, I now have a point at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So to actually get a grid, what I need to do is I need to graft either this series of numbers or this series of numbers. I could do that either here, or I can do that here. So right click on Y and graft, and that will basically, it's using this value with each one of these values. So the 0 value here is used with the 0, 1, 2, 3, 4. The 1 value here is used with the 1, 0, 1, 2, 3, 4, but I have to graft it there. So why would I do this? This is something I haven't explained on the blog itself. Just a few ideas. One of the things you might want to do is, I'm just going to make my interval very small right now. Just point, let's just say 0.2. And make that 0.2. And I'm just going to zoom in very, very close here. One of the things you could do is you could use the graph mapper component, which is explained in a future example. But let's just say you wanted to use a graph type, this concave graph, And what this is doing is it's remapping. It only remaps numbers between 0 and 1, so that's why I use these very small values, 0 and 1. And you can just see here, if I put a panel down, 0, 0.2, 0.4, 0.6, 0.8, and now it's basically remapped those. And so let's just put that in here, and you can see what it's done to my grid. So then I could tweak that here to just get a slightly different custom grid. So it's not really a grid anymore, but this is just one of the reasons why you might want to go through the headache of setting up your own customized grid for the base structure. So I'm going to get rid of those, and we're going to go back. If you want it to be bigger than these small values, you could actually then take these values and then you can multiply them by a factor like 5. And this will basically get you back to a bigger grid if you want. So we're going to get rid of that, and we're just going to go back to our basic grid structure here. And we'll start off with a 5x5 grid for this particular example. Once we have our customized grid set up, we are now ready for the next step, where we will be drawing our actual rectangles. Now, drawing a rectangle is a bit more complicated than drawing a, say, a circle or a polygon. And we'll see why in just a second. So here under the 5th tab, under curves, primitives, we find our rectangle component here towards the bottom. And let's just drop that on the canvas. Again, we want to draw a rectangle at each one of the points. So we're going to use our points here as an input into the P, the plane of our rectangles. Now we can't really see the rectangles because they are actually quite a bit bigger than the grid that we've set up. If we hover our mouse over the X size, we can see dimensions of the rectangle in plane X direction are -1 to 1, and in the Y direction they are -2 to 2. Let's just, for the sake of making this a bit clearer, I'm going to drop a slider on 0.25, and I'm going to plug that into the X input, and another slider 0.75, and drop that into the Y input, and you'll see that now I have rectangles. Now the problem with the rectangles as I've drawn them is that they're using the origin as this bottom left corner, and that's because when I plug these two values in, which worked for the polygon, it worked for the circle, but what it's done is it's overridden the domain. Let me just disconnect that right there. Disconnect that input we've drawn. So the domain that it wants is from a negative value to a positive value, equal in both directions. But what we've plugged in is a value from 0 to 0.25. So if we want to do this properly, what we'll need to do is take the negative value of what we've drawn, and what we'll need to do, we'll do that for the Y as well. So we're going to use the negative component. You can just double click and type negative. That's found up here under maths operators, negative. So this will give me 0.25, negative 0.25 to 0.25, and I could construct a domain, math domain, construct a domain between that negative value and that positive value. And I can use that as my input instead. And I'm going to use the same thing, just copy over this domain. So from negative 0.75 to positive 0.75 as my Y domain. Now, this has given me values that I can use. Let me just make this a bit smaller and that a bit smaller. But basically what it's done is it's, if I use the value 0.38, so I wanted this to be, my rectangles to be 0.75 long, but it actually made them twice as long as what I wanted because it's going from the negative of that value to the positive of that value. So I could just pull my sliders back and I get what I want. But a better method would be to just use the division component, which is up here under operators, division, to divide this initial value by 2. So I'm going to take that initial value and I'm just going to use the a panel. To get a panel, you can actually just double click the canvas and type panel, or you can just type quotation marks and then type the value that you want, 2, and that will give you 2. So now I have half of the value, the y direction I want for my rectangle, and I'm going to use those for the negative and the extents of my domain. So we're going to just copy this over and do the same process for this second value. And so now I have quite a bit going on right here just to get my rectangles drawn as I want them. But now they are going from, so I have two rectangles in the x direction. They're going from, and if I hover my mouse, negative 0.125 to positive 0.125, which is half of 0.25, and then the y direction here. So I'm just going to rename this parameter, so I can just double click that, or I can right click here on the end, and then up here in the top in this box, rectangle vertical dimension, and then rectangle horizontal dimension to establish my parameter. So quite a bit is going on feeding into here to get these rectangles set up properly. But once we have them set up properly, we can now use our sliders to adjust the starting size of these rectangles. We could scale the rectangles now. We could scale the rectangles. We could rotate the rectangles. But in this particular example, what we want to do is be moving them in a random value in each direction, which we'll do in the next step. So once you have your rectangles drawn, we're now ready to move on to the next step, where we are going to be moving our rectangles a random amount in the x direction. And what we're going to want to do first is to set up a random number generator to produce the values that we're going to use for that movement. So in the scaling circles example, which is linked in the description, you can see a bit more on random number generators, but we'll go through it again here in some detail. So here under set sequence, the bottom is the random number generator. You could also just double click, type random to get that. And what this wants, the three values it wants, is the range of random values. So the domain, 0 to 1 is the default. We want to move our rectangles either in the negative x direction or the positive. So what we're going to do for this is here under math, domain, construct domain, we are going to make a domain, and it is going to be between, let's just say our minimum value will be 0.25, and I'm going to actually just use this one slider to do both inputs in the negative and the positive direction. So here under operators, negative, so it'll go from negative 0.25 to positive 0.25. I'm not going to bother dividing this by 2 as in the previous example, because I want to be able to say from negative to positive of the value that I'm defining in the parameter. So that is going to be plugged in to my random number generator. So now I'm producing only one value right now, and it's giving positive 0.135547. I basically want a number of random values equal to the number of rectangles I have. So to do that, I'm just going to move this up. I'm going to use the list length component, which is found here under set, list length, drop that on the canvas, and then draw a wire from the rectangle to the list length. And then this is now going into my random number generator. We can now see the series of values I'm getting. And if I want to just have each rectangle have its own series of values, I actually have to go back a bit earlier in the script. I'm going to go all the way back here to this point, and I'm going to right click that and flatten. And now it's giving me a unique value for each individual rectangle. We'll go back and unflatten that to just see what happens if I if I want each item in each row to have the same value. So let's now we're ready to move in the X direction, and move is a transform. So here under the I think it's the 8th or 9th tab, transforms. Here Euclidean, we have move, the second item in this list. So what is the geometry when we want to move our rectangles? So we're just going to plug that into geometry. And what is the amount we want to move them? And it's asking for a translation vector. So this is an amount either X or Y, or it could also be in any vector. We haven't really talked much about vectors yet, something we'll talk about in great detail later. But this will give you a clue as to what you need, a translation vector. So here under the vector tab, the last subgroup under the vector tab is this unit X. And I can just drop that on the canvas, and this will give me an X vector. I've actually moved them. This is actually the movement because it has moved them 1 unit in the X direction. But basically I want to use my random number generators and plug that in to the unit X. And let's just turn off my original series of rectangles just to see what's happening. So right click, preview off, and you can see here it has moved them based on those random values. If I come here under the seed and I put in a new number for the seed, and I often just do 55.55, I'm not sure why, and we can change that seed, and you can see that we have this jitter going on, so it's moving them randomly, either negative a negative amount up to 0.25 or a positive amount up to 0.25 again. And I can decrease the strength of that or increase the strength of that as I see fit. So the next step is going to be exactly, well, generally like the previous step, but we are going to be moving them a second time, but this time in the Y direction. To do this, I'm actually going to take all of this stuff here, our random number generator, the domain, our list length, our seed, and I'm going to Control C, Control V, and I'm going to move it after this second move. I could just use the original list length, but just to keep it a bit cleaner, I'm going to use this geometry as my list length. It won't make a difference. There's the same number of pieces of geometry either way. But let's just do that to so we can see what's going on. So it's measuring the number of geometry to move. Now we want to move the geometry that's already been moved once. And we're going to do a second move transform. So here under transform Euclidean move, and then I'm going to use that same piece of geometry, but this time instead of moving in the X direction, I'm going to use Y. I could come here under vector, sub-tab vector, and then pick the unit Y. You can also double click on the canvas and just type Y, and that unit Y vector component will pop up. So I'm going to pop in those random values here, and then use that for the T. We're going to turn the preview of the original things off, and now let's move that here. Now you will notice, if you're a careful observer, that the amount of X movement is always equal to the amount of Y movement, because we have the same random seed. And if we want that to be different, we just need to change the seed ever so slightly to give it its own unique set of random values. So if you use the same seed with the same list of numbers, you'll have the same values, and so we don't want that duplication happening, so we can do that. I can make it so that the Y jitter is stronger or weaker than the X jitter as I see fit, depending on what my goals are. So I'm going to make the X jitter actually slightly stronger than the Y jitter in this particular example. So just a little bit for Y. Try a few different values for that value here. I'm actually going to go back and I'm going to turn off the preview of my points just so I can see the final output of my rectangles. So in our final step, we are going to give each one of these rectangles that we've drawn a unique color. If you've been following along with some of the previous examples, you know exactly how to do this. Here under surface freeform boundary surface, we drop a boundary surface component. It gives it that default color. Then here under display, preview, custom preview, plug that in, and then here under primitives, input, color swatch, we're going to give it a color. Let's give this a nice something in the greenish range. And let's turn the preview for our boundary surfaces off. It's actually more yellow. Let's try to give it a bit more green. Play around, and that'll be fine. Just a few other things I want to do. I just wanted to make my rectangles a bit thinner. So if I come back here, sorry, I have to go back even further. The horizontal dimension, I'm going to make my rectangles a bit thinner and a bit longer. And I'm also going to come back here to my grid, and the step size for the X direction, I'm going to change that to 0.25. This is another reason why you could set up one of these custom grids if you want to be able to change one of the parameters easily, which you could do actually with the rectangular grid anyways, but it's just something you can do. So I'm going to just come back here, make that a bit smaller, and now I have my jittery rectangles. Play around with the seed just to change the jitter a bit, and then the seed here as well. And let's just go big. We'll just increase the number of rectangles to finish up this particular pattern. If you found this example helpful and you would like to have a copy of the completed version of this script, a bit cleaned up, with the parameters clearly labeled and categorized, you can come to my blog, generative-landscapes.com, and you can, under the downloads, you can purchase this for a small fee. This would also help support the blog and the channel, and would be greatly appreciated. So this is included with the two previous examples, the scaling of circles and the rotating of polygons. So you'll get all three of those at the blog generativelandscapes.com with one single download. So thanks for watching.